I thought I'd start by telling you a bit about who I am and what I do. So I'm now based in engineering at UCL, so I'm a professor within mechanical engineering. I run the Institute of Healthcare Engineering. Most people would probably think I'm an engineer. I'm not. I'm a mathematician. So really, when I was young, when I was a kid, I just really liked maths and science, but most of all maths. And I never had a game plan at all. I basically just followed my nose and did what I was interested in. So I like maths. Most people think that's really strange. It's not generally a conversation starter, but that's the way I went through things. So I basically applied to uni and did maths there and continued to really enjoy it. I did discover at university that I wasn't very good at pure maths, which I thought when I was younger that like all maths was pure maths basically. So I basically specialised in applied maths. I really liked fluid mechanics. And I moved into mathematical biology, basically. So basically, there was just an opportunity to do a PhD with a particular supervisor who I'd done a project with, and that was in using the kind of maths that I'd really enjoyed in my undergrad, but applied to modelling blood flow in tumours in tissues. But it was very theoretical. It was really from the point of view of worrying about what the equations were and how you could derive them on different length scales and how they related to each other, and it was loads of Greek letters, and I absolutely loved it. And still do really love the math side of things. So basically at that point I got really interested in trying to use maths to understand biology, which was kind of interesting because I'd given up biology when I was like 15 at school, because at the time I didn't really like it at all. I kind of found it to be kind of rote learning, and that didn't really align with me at the time. So I basically had no biological, or next to no biological understanding of anything, but at this point got kind of interested in how you could use maths to understand biology, and then how you could use maths or computation as a predictive tool to try and get information out of biological systems. But that obviously involved a lot of reading and trying to understand about another field, and learning to get good at just asking questions of people that were probably really daft, obvious questions to them, and not being worried about being in a position where you would ask those questions. But I also really enjoyed the opportunity to talk to people from different disciplines. I think if you're someone that's kind of got the research bug in you, if you like, then it's great to be working in areas where you always know there's new things you can learn about, and this kind of really worked for me from that point of view. So I then moved on to doing a research fellowship, which was fantastic, and because I had the freedom and the flexibility that comes with having a fellowship, and I was, I think, extremely lucky to have that at that point in my career. And at that point, I was really kind of passionate about interdisciplinary maths and that kind of thing, but I also really wanted to try and use the maths and the kind of really theoretical stuff that I did to have some kind of impact. I was quite passionate about the idea of trying to use maths usefully to have an impact on people's lives in some way, although that sounds quite cheesy, but that was kind of the motivation there. There was a big gap because I basically A, didn't know anything about biology, and B, had never done an experiment in my life. So at that point I really needed to get experience of what biologists, for example, did, but because I was in this lucky position where I had this fellowship, it meant that I could try and get that a bit. So I'll tell you a bit about that in a moment. And then ultimately, I basically kept on following my nose in these directions and moved into biomedical engineering at UCL, which has been wonderful because I think most of you here are probably from UCL, but UCL in general is a very kind of collaborative environment, and that worked really nicely for someone who was in my kind of position at that time, because I wanted to find people to work with and work on interesting problems, and I found it a really great environment to try and take that approach. So I moved here in 2012, I think, and I continue to do interdisciplinary research in these kinds of areas. So I work basically in computational mathematical modelling in healthcare. And then I also help run various institutes and centres where we think quite carefully about how we can try and engender this kind of culture of collaboration and interdisciplinarity at UCL. So I'll tell you a bit more about that later as well. So in terms of the actual research I do, it kind of feels odd not to give a talk and at least tell you a little bit about the research that you do. But now I've focused really on using maths and computation as a tool, both for understanding how therapies get distributed in tumours and how you can try and use that to predict how to optimally treat specific tumours, and then also as a tool in tissue engineering, specifically for nerve injury repair. But the list on your left there is really an indication of the kind of breadth of the teams that we try and bring together to tackle these kind of problems. And I think it's fair to say that there's a whole range and an increasing number of really exciting problems to tackle in medical sciences and healthcare, for example, where to make progress you really need this diversity of different approaches. So it's a real challenge, but it's also something that's really exciting, because I think it's really interesting if you spend your time trying to learn a lot from lots of different people and try and pull together all the information. So I think you've talked quite a lot about today about kind of CVs of success and CVs of failure, and I personally think it's really important that as academics we become much more open about the things that went wrong along the way and the things that went right, and we don't just present all of the successes, if that makes sense. So this is a kind of summary about how my kind of career path took off, or how it's navigated through. So as I said, I did my degrees in applied maths. I moved into biomedical engineering, big focus around those times around trying to build independence, build teams, build research groups, and to get funding to support that. I'm going to tell you quite a lot about the things that went wrong and the things that ended up helping me in trying to make that more successful. But on the top there, I've kind of summarised all the things that went wrong in trying to get there. So I was extremely lucky, and it is luck. That I had a research fellowship following my PhD, but to get there, I mean, it was quite interesting. So I went back through my old files on my computer, and there's long lists of all of the things that I applied to that were just failures, right? And there's at least 15 fellowships, 5 lectureships. It's of that order. So plenty and huge amount of work as well that goes into all of those, and also each one of them rejections, building yourself back up and trying again. When I started trying to build my research group, there's a whole load of rejected grant applications that I have in my folders as well, which Mark probably remembers quite a few of them, because Mark has his office just about opposite me, and I think I probably went and moaned at him pretty much every time that I got a rejection and asked for input. But grants from the BBSSE, NC3Rs, CRUK, etc., etc. So I'm going to talk a bit about how I ended up doing all of those things, and then how I kind of tried to shift what I did based on feedback and input that I got, and how I think that helped. So when I was an early career researcher, so as I said, I was a mathematician, and I had this kind of disconnect because I was very much a theoretician, and I loved the maths, and I still really do. It's kind of pen and paper maths, and but I kind of wanted to use that in a way that was impactful and could have an impact on people and that kind of thing. But there's a big disconnect between those two things. But I guess what I did think about at that stage was kind of where I kind of wanted to be, or what kind of research I wanted to be doing. So I knew at that stage I wanted to use the maths to have an impact on health in some sense, and I also knew that I really liked multidisciplinary research. So I loved this capacity to talk to lots of other people and kind of work together in teams and that kind of thing. And I was lucky because the environment that I was in had been very supportive of that, so I was given a lot of freedom, and it was also a very collaborative culture, which I was extremely, I think, lucky to have at that stage of my career, and I think it's something that we all need to think about in terms of how we try and support our students and early career researchers at different stages. I also loved the independence, so my PhD supervisor was extremely hands-off, which had its challenges, but also meant that I got very used to being given a lot of freedom myself. So I think by the end I only saw him every few months, which is a massive challenge when you're writing thesis chapters and you don't get any feedback. But it meant that I wasn't used to being managed in any sense, and I kind of really loved that freedom and that independence. I also knew that I wanted security, so I was married when I was a postdoc. I didn't have the flexibility of moving all around the world, doing different projects, and I kind of wanted to be settled and living in one place and not have instability. So there are kind of a lot of difficult things to try and address as an early career researcher. So there was a lot of trial and error. So I talked about failed fellowship applications, so I've listed some there, but there are a whole host. But really the thought process at the time, and I think a lot of people are like this, I didn't really put a lot of thought into it other than that I thought I should just try every opportunity that came knocking. So I literally just went looking for every kind of thing that you could apply for at that stage and applied for it. And it was kind of scattergun, and it wasn't really informed. And I kind of shoehorned what I thought I wanted to do into whatever bids you could write about. And a lot failed basically, and I found that really difficult, and I got stressed about it because contracts come to a close and you're worrying about what you're going to do next and all these kind of things. But reading the feedback of those applications was really important, and in some ways it was really hard because obviously quite a lot of them were very deeply critical of what I was doing. So I had biologists reading what I was doing and not understanding the maths because I hadn't explained it very well and thinking it wasn't valuable to be combining the two. I had mathematicians who thought that the biology wasn't very relevant or not liking that side of it, and then very valid criticisms about how I was piecing the two together. So I think there's a real trick there in kind of going through the feedback that you get and learning to dismiss the stuff that kind of isn't fair or isn't right, but actually reading it properly and thinking very carefully about the feedback that is fair and that you can try and use to move forwards and improve things. So the really important things that came out of that were bang on the money were that, first of all, I needed to know much more about biology and much more about experiments. So I was basically sat in my maths bubble, kind of pretending that I knew how I was going to use maths to inform experimental work without ever having been in a lab, so it was very fair. The second piece of feedback, which I think is something that, again, was really highly relevant, was that it was really important to have experience of different environments and different institutions. So I'd been in Oxford, I loved it, it was amazing, I was super happy, I'd been in a great environment. I didn't want to leave, but of course I had to leave. And actually accepting that and being much more proactive about how I tried to do that was much more productive than just ignoring the advice and pretending and hammering on through. So the other thing I think that's really important is that a lot of these schemes and grants and things don't often they sometimes don't give feedback unless you really push for it. So I think it's really important to keep pushing and ask for that feedback so that you have the opportunity to try and learn from what went wrong. So what did I do at that stage that really helped? So I kind of took a step back and thought about what I really needed to do to address some of these issues. So I needed the biology and I needed the experimental experience. So I ended up basically going and working in some experimental labs at different institutions. And these were really just kind of ad hoc relationships that I met people through conferences or through networks and things, and then asked them if I could go and work in the labs a couple of days a week, and people really open to that. I think one thing that's really important is to kind of have the confidence or to go and ask people, because people are usually really supportive if you're proactive about seeing what the options are. So I spent some time in Bath kind of doing experiments, and a brilliant person there called Marianne Ellis taught me how to feed cells and look after cells and work on bioreactors and things like that, and that was fantastic. And then I also did some work at UCL, which was brilliant. I also made a decision at that stage that because I'd come from a maths background and was trying to move into these other fields, I stopped going to any maths conferences and just went to tissue engineering, cancer conferences basically, which I understood absolutely nothing of at all. But I think that was really important in just throwing myself in at the deep end and learning how to talk to those communities about the kind of research that I was doing, and also recognizing that I kind of knew people that did the maths. So I knew who to ask and who to work with if I had issues in that side, but I needed that network and those kind of people to work with from the other side. I just wanted to say something about mentors and supporters as well. So I think it's really important to find mentors or people that you can talk to and ask advice from. So at this stage, these were three people that were really kind of influential to me in terms of they were people I could just go to and ask advice of, and were, had kind of followed similar paths of doing kind of interdisciplinary science and research and that kind of thing. And I think that is incredibly valuable. And I would really recommend any of you who are at that kind of career stage to think about finding those kind of people that you feel comfortable going and talking to and getting advice from and input from. And again, I think it's going to be a theme a bit through my whole talk, but people are kind of everything when it comes to science. It sounds a bit corny, but research is really a people endeavour, and none of us can navigate it without the support of people around us. So if you find those people and run with it. So then ultimately I did all this, and then I ended up at UCL, which was brilliant. As I said, it's been a fantastic environment for the kind of research that I did, but I kind of then restarted, right? Because you then start with a permanent academic job, and that's brilliant. But then you need to build your own research team, and it's a whole new set of challenges. So again, I kind of knew what I wanted to do. So I wanted to do multidisciplinary research in these kind of areas, and I wanted to build and support a research team. But again, how do you do it? And I kind of made a lot of the same mistakes again, and I didn't really realise it at the time, but again, my approach was very much scattergun. I basically looked at all of the places that you could apply for grants for that were kind of vaguely relevant to what I did, and I applied for them all at different, I just kind of wrote loads of applications and things, but I made a lot of the mistakes again, same mistakes again, essentially. So there are some of the places that I applied to. Another thing that I really struggled with at this stage in my career was lack of focus. So I was kind of interested in loads of different things, and I came to UCL, and I remember looking on websites and finding people that were really interesting and emailing people, and literally everyone that I emailed or contacted with said, yes, that's brilliant, let's have a coffee. And then suddenly, and that was fantastic, and it's amazing that it's the kind of environment that happens. But it suddenly meant that I had all of these different people who were really interested in potentially working together, and they were all working on really interesting problems. And it was just impossible to manage. It was completely infeasible, really. But I didn't really realise that at the time, because I was just like a kid in a candy shop, really, just like, oh, we could do all of this fun stuff. So these were all different themes of research that I kind of kicked off either through undergraduate projects or PhD bids or grants and things. And I mean, retrospectively looking back, it was kind of crazy, but it seemed really natural at the time. But one of the challenges that I really had is that, if you're a mathematician trying to work in a biological field, you need to understand the biology, and there's no way that I could understand the biology of all of these different things from scratch. It was never going to happen. So basically, I spread myself far too thin and wasn't structured and rational enough about prioritising what to do when and how to build things up. So again, how do you make informed choices about what made things better? So these are some things that really helped. So mentoring again, talking to people, getting advice. So I think I found that the advice isn't necessarily going to come to you. You have to go out and ask for it. So I think finding people that you feel comfortable going and having those conversations and asking for advice from is really important. And they can guide you on things like what funders, I was applying to the wrong places really for what I wanted to do, but I didn't really understand that or realise that at the time. Get input and feedback on grants before you submit them. It sounds really obvious, but again, I didn't really know you could do that. I just wrote stuff and submitted it. I don't know, it didn't really occur to me. I was probably very naive. But once I realised that there were people who were prepared to sit and read your grants and give you, who had been successful in getting grants themselves and help you out with how to pitch them, that made a big difference. A balance between playing the numbers game. So I think with any of these things, whether it's grants, papers, et cetera, there's always going to be rejection, and there's always going to be a numbers game. So to some extent, you have to put them in, knowing that some of them are going to be rejected, and that if you don't put them in, you're definitely not going to get them. But I was definitely getting the balance wrong, and I think it's really important to try and focus too. So I focused on a couple of specific areas that is still my main focus for now. So cancer imaging and therapy and nervous system tissue engineering. And the reason that I focused on those two areas were really, partly because I found them really interesting and exciting, but partly it was really people-based. So basically I found two people who I get on really well with, we're good friends, and we could really work together, and I enjoyed working together with them, and we communicated well, and it was basically really fun to be able to try and build teams together with them. So these are those two people, so Simon Walker-Samuel, who's based in Cabby, and James Phillips, who's based in the School of Pharmacy. And that worked really nicely, and I would really advocate that as an approach. It's really worked nicely for me. It's not to say that I'm not interested in other things or I don't still work in a few different areas and things, but having that focus and having those personal connections with people that you really get on with on a personal level, and therefore kind of think similarly about how to manage people and grow teams and all that kind of stuff, is really important, as well as having the scientific connection, if that makes sense. I've got a final point there, which was around jumping up opportunities when given them. So So I think in general, I found UCL to be a really permissive environment if you've got ideas and want to do things and set things up. So I think there's a lot of, if you've got ideas, you should run with them. And if people give you an open door, run straight through it and set things up. So that's another thing that's, I think, is really important. So I wanted to say a few other things about factors that have kind of influenced me in my career and so far at least, and things that I think are really important to think about. So I think one thing that's quite typical of academics, and probably people who aren't academics too, is that we're quite self-critical and I think not very good at realising our own limits. So at multiple points along this kind of path, I would just apply for loads and loads of things and put a lot of pressure on myself to be getting everything right when I didn't need to. So one specific example I wanted to give is that, so I've got 2 small kids. So I remember when I came back from maternity leave from my first son, Sammy, he got quite sick. So there was a period of 3 months basically where I'd just not long come back from mat leave. He was then out of childcare for 3 months, really quite poorly. And I had, retrospectively, I had the complete support of everyone around me. No one put any pressure on me whatsoever. But I never realised that. So for me, I still put all the pressure on myself to be doing everything that I should have thought I should have been doing. I was still putting in grants, which all failed. And I was pushing myself to a limit that didn't work. And I think that's something that I learned a lot from. I still get it wrong quite a lot, but I think it's really important to know when you've got support around you, how to use that support and kind of be kind to yourself. So I think the last thing that I wanted to say was really around building an interdisciplinary research team and what I think is really important if we're going to encourage these kind of cultures. So it sounds kind of obvious, but if you've got people from lots of different disciplines together, you have to have an environment where people can communicate and are able to ask questions from people from different backgrounds and feel comfortable in doing that. So I think creating that kind of culture is really important, and also the diversity that comes with these kind of teams is amazing. So it can be really challenging because there's lots of different people who are all individuals and they all need different things to support them, but the added value of having all of those different inputs on how you do research is incredible. So celebrating successes. So Mark is someone who's always said to me, if you get a grant, you should go to a matinee or something. Like you should just leave and celebrate it. And and I've kind of not listened to him much, which is my own fault. But he's right, and I think when other things do go right, we need to celebrate them and enjoy them before we run on to trying to do the next thing, and basically supporting each other.